We're here checking out the graphing motion practice problems. And so I give you a scenario of a runner and ask you to sketch her relevant graph, corresponding graph. There you go. So we look first, number one, runner standing in front of the starting line at rest. So she's just standing there at rest at the same position the whole time. So that's going to be a line of constant position. So just nice and horizontal right here, right? Remember, the slope of a position time graph is velocity. So this would tell you that she has zero slope or zero velocity, which means she's at rest. All right, second one here, runner. Now she's sprinting at a constant velocity away from the starting line. Again, slope corresponds to velocity. So she has a positive constant velocity here, and we need a slope that is positively constant. Okay, so our graph would look like that. So we have a line of positive slope representing a positive velocity of our runner. She turns around and she sprints back towards the starting line at a constant velocity. So now if this were a positive velocity in number 2, we have a negative velocity in number 3. And I see I don't have any room down here to do this, but it would be right down here. Oh, LT, wrong, dude. That didn't happen, everybody. So that means constant negative velocity, we need a line that is constant negative slope. So she would be going back to where she started, and we have a slope that is negative. So here's a negative velocity represented by a negative slope. I did it. All right, let's move up here and check out the next 3. She's accelerating out of the blocks, positive acceleration. So we want to represent a positive acceleration on our position time graph. So again, slope is velocity. So if our velocity is increasing, right, our velocity is going to increase to show an acceleration. So I need to see my slope is increasing. So I have a line where my slope is lower, my slope gets steeper, 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 steeper. So there my slope is constantly increasing, and hence I have a positive acceleration rate here because my velocity is constantly increasing. All right, number 5, a couple different things going on here. She's sprinting at a constant velocity and then negatively accelerates to a stop. So maybe this is her crossing the finish line at a constant velocity, and then she negatively accelerates to a stop. So 2 motions on this graph, constant velocity and negative acceleration. So we want to show that she has a constant velocity, like this, and now that slope is going to decrease to 0. So here we have a positive slope for a positive velocity, and now my slope is getting less and less and less steep to show that we have a negative acceleration rate to a velocity of 0 here, right? Because this would be 0 slope. So again, if I look at this, positive velocity, positive slope, and now my slope is going to decrease to 0. So if my slope is decreasing, my velocity is decreasing there as well. Hence my curve here. Number 6, oh, this is the one I tried to draw before. Now it says, describe the motion of the runner from the graph. So here's a position time graph. Here I have a negative position, right? Here's the negative numbers down here. So looks like she's at rest at the negative position behind the starting line. So I would assume that she's probably going to be standing right here, okay, at a negative distance behind the starting line, right? Okay, so that's what this shows right here. This is a negative distance. And she's at rest, right? Because the slope here is 0. So that means her velocity is 0. She's just standing still. Carry on, everybody. So now we're looking at velocity time graphs where the slope tells you about acceleration. So here, runner sprints at a constant velocity. We assume that's a constant positive velocity, which means she is not accelerating, right? When I see constant velocity, that means acceleration is 0. So that means my slope of this graph has to be 0. So whatever her velocity is, it's constantly the same number. and we have an acceleration rate of 0 there as well. Ooh, number 8, describe the motion of the runner from the graph. So here we have a negative constant velocity, right? It's a negative velocity and it's constant. So that means she is running backwards the other direction, right? She's going back towards the starting line. Okay? So she would be moving this way at a negative constant velocity. Okay? Number 9, runner accelerating out of the blocks. So here she's accelerating and increasing her velocity at a constant rate. So we want to show a positive acceleration here. So we need a pot line of positive slope. So something like this. Okay, so there our slope is constant and positive, showing our acceleration is constant and positive as well. Last ones. Are we done? Are we done? Oh, we did it, everybody. Fantastic. Thanks for checking out those problems, and we will see you in class. Oh, I lied. Just kidding. There's 2 more. No, there's a 10, A, B, and C. All right. I knew there's 4 pages. So number 10, describe the motion of the runner from a given graph and sketch the missing graph that corresponds to her motion. It's all about slope, everybody. All right, so let's look at the given graph here. I'm going to make my pen a little smaller. Can you guys see that? Maybe. All right, let's make our pen a little smaller here. So let's look at A. So here we have a line, so it's a positive slope, right? And so again, positive slope and the slope of position time graph tells you about velocity. So this positive slope means she's going at a constant positive velocity. So to sketch that over here, a constant positive velocity would be just like that, right? And again, constant positive velocity, the slope of this line is 0. And again, the slope of a velocity time graph tells you about acceleration, so it tells you that her velocity is constant, right? She's not accelerating. All right, it all correlates. That's the word, everybody. So let's see, for B, 2B, no, 10B. 10B, or not 10B, that's the question. Velocity time, so here we have velocity time. It looks like it's a nice negative velocity, that's constant. So we need to show a constant negative velocity over here. And so velocity is slope, so we need to show a line of negative slope. So I think that's going to be something like this, everybody. All right, so there's a line of negative slope, and it's constant, right? All right, last one, 10C. We have our, it's not even a line anymore, it's a curve. So here we see, again, slope of a position time graph tells you about velocity. So here we see the slope is increasing, which means our velocity is increasing, right? So we have a slope that is like pretty flat here, and the slope gets steeper and steeper and steeper, right, as we go, hence making the curve. So we show our velocity is increasing. That just means we have a positive acceleration rate here. So how do I show a positive acceleration rate on a velocity time graph? Well, slope is acceleration on a velocity time graph. So if I need to show positive acceleration, I need a line of positive slope. So it's going to be something like this. Okay, so our positive slope shows us our positive acceleration, right? Which shows our velocity is increasing with time. All right, that is officially it. Thanks for checking our answers to our position velocity time graphs.